Hello everyone, good afternoon. This is Dr. Vijay Raja and I am here to talk on the complete oxidation of glucose. Glucose is the ultimate fuel molecule which are from the carbohydrates that we are ingested, and these glucose will undergo glycolysis, TCA cycle and electron transport chain to produce ATP. So every glucose molecule fate is to produce ATP through complete oxidation. The aerobic respiration is a metabolic process in which oxygen is used to convert carbohydrates, fats and proteins into energy in the form of ATP. That is the energy currency of cell. And this process is the most efficient way to generate ATP. And aerobic respiration takes place in the mitochondria of eukaryotic cells and in the cytoplasm of prokaryotic cells. The process involves several steps including glycolysis, the Krebs cycle, also called as TCA cycle, and the electron transport chain. During glycolysis, glucose is broken down into two molecules of pyruvate, and also it produces a small amount of ATP and NADH. The pyruvate molecules then enter into the mitochondria by converting into acetyl-CoA and are further oxidized in the Krebs cycle, which produces more ATP, NADH and FADH2 molecules. Finally, the electron transport chain uses the electrons carried by NADH and FADH2 to produce a large amount of ATP. So this is how the glycolysis, TCA cycle and electron transport chain are getting integrated. All this integration is to bring out the process of producing ATP molecules. Glycolysis takes place in the cytoplasm of a cell. TCA cycle and electron transport chain takes place in the mitochondria of a cell. In aerobic respiration, ATP is efficiently produced through the integration of these cycles, glycolysis, TCA and electron transport chain. So in glycolysis, which is the first process, as we said earlier, the glucose is converted to pyruvate and ATP molecules, and it enters into the mitochondria to take part in the TCA cycle. Before that, it is converted to acetyl-CoA. In the TCA cycle, the acetyl-CoA is further oxidized to produce NADH, FADH2 and ATP. The NADH and FADH2 molecules produced in glycolysis and TCA cycle then enter into the electron transport chain, where you can find a series of protein complexes embedded in the inner mitochondrial membrane. As these electrons are passed through the electron transport chain, they generate a proton gradient across the membrane, which is used by the ATP synthase to produce ATP. So in this process, the energy generated by the breakdown of glucose through glycolysis and the TCA cycle is ultimately transferred to the electron transport chain, where it is used to produce ATP. So the entire process is compactly regulated to ensure the efficient production of ATP and the maintenance of cellular energy homeostasis. So this is a very simple illustrative of how the glycolysis, TCA cycle and electron transport chain are getting integrated, and how many ATP molecules and NADH are produced is clearly illustrated in this picture. So regarding the energetics of the complete oxidation of one molecule of glucose, through all the process of glycolysis, TCA cycle and electron transport chain, the final number of ATP molecules produced are 38. So one molecule of glucose is getting oxidized completely to form 36 to 38 molecules of ATP molecules. This ATP production might be directly generated from the substrates. So wherever you can find glucokinase and you can find the ADP involves, and ADP combines with phosphate to produce ATP. And wherever you can find the generation of NADH, and FADH2. One molecule of NADH will produce 3 molecules of ATP, and one molecule of FADH2 will approximately produce 2 molecules of ATP. So all this combine and forms 38 molecules of ATP. So this is what we are getting when a complete oxidation of glucose molecules takes place. Hope you get a clear view on the complete oxidation of glucose. To this process, there is number of enzymes which are getting involved and promoting the glycolysis electron transport chain and also the TCA cycle to produce the ATP. So the glucose is the ultimate source of energy, which is from the diet whatever we ingested, and that glucose enters into the bloodstream, which is getting transported into the cytoplasm through the channels where the insulin comes and promotes the entry of glucose into the cell, and with the help of various glucose transporters the glucose enters into the cell, and in the cytoplasm the glycolysis happens and it is converted to pyruvate and then to acetyl-CoA and enters into TCA cycle, and from there in the form of NADH and FADH2 it enters into electron transport chain and produces ATP. So this is how the glucose are producing ATP molecules. Thank you. Thank you for your patient listening. Thank you.